Hi, I'm Mark Serzano, registered piano technician with the Piano Technicians Guild, and I have a website, howtotunepianos.com. And in my website, I have a course on how to tune pianos called the Go Ape Aural Piano Tuning System. This course was developed with the purpose of trying to give people accurate information on how to tune pianos. There are a lot of myths out there, and these myths make it difficult for people to learn how to tune pianos because if you follow the instructions given with these myths, you end up getting bad results and you don't know why. Well, the reason is because you're following instructions that are wrong. For example, a lot of times people are told that perfect fourth beat at 1 beat per second, or another course says that perfect fifth beat 3 times in 5 seconds. So let's show you why this is wrong. So we're going to start with a table. We have A4, which beats at 440 hertz. Let's add all the notes below this. Okay. Now let's try and fill in this chart. First of all, we can get A3 just by dividing by 2. We end up with A3 at 220 hertz. And now what about all the notes in between? Well, we can use the equal temperament ratio. Equal temperament is a system where the piano can be equally out of tune in all 12 keys. And we use this system, we create this system by multiplying each frequency by the 12th root of 2. That's the ratio for equal temperament, and it's about 1.05946, which means each semitone is about 6% higher in frequency. So let's try it. But as we calculate all these frequencies, when we get to A4, it has to equal 440 or else the system is not working. So as we multiply each frequency by the 12th root of 2, we get up to A4, and indeed it equals 440. So this system works. Now what about the harmonic series? The harmonic series is a series of frequencies above each note that are present in each note, and it's these frequencies that allow us to hear the beats when we're playing an interval. We're going to calculate all of these. The first partial is the fundamental, also known as, and is given by the frequency of the actual note. So we're going to calculate up to 6 partials. And how do we do that? It's a very simple calculation. Simply multiply the partial number, in this case 1 to 6, by the fundamental frequency. So 220 times 2 is 440. The third partial, 660, and so on. Now, what about the other ones? You do the same thing. Multiply the fundamental frequency by the partial number. And there you go. Now for all the rows, we get all the partial frequencies of these notes. And let's just do the same for the lower notes below A3 and the partial frequencies. Now that we have this chart here, we have to ask ourselves, well, what does it mean when someone says the perfect fourth beats at 1 beat per second? What beats? Where does it beat? Why does it beat? In order for us to figure that out, we look at the chart again. And let's consider the perfect fourth F, B flat. This one here. Now, piano tuners always talk in sharps. That's why I got that A sharp there. So each of those notes has a harmonic series. All those frequencies are beating at the same time when you play the note. And some of those are very close. Take a look at these. That's the fourth partial of F3, the third partial of A sharp 3. They're very close. So the beating that occurs at these coincidental partials is calculated by the difference. Difference of the frequencies. Simple as that. So the F3, A sharp 3 beats at a speed equal to 699.2 minus 698.5, 0.7 beats per second. Well, that's not 1 beat per second, is it? What about the other perfect fourths? Let's alter our chart a tiny bit. In this column, we're going to put the perfect fourth, and that column we're going to put how fast it's beating. So we have our F3 A sharp beating at 0.7. Now this is only 1 decimal point, so we're going to go to 2 decimal points just to make it a little bit more accurate, let's say. And what we do now is we simply calculate the other ones the same way. So F sharp B, just take the difference of the fourth and third partial, and so on and so forth. Once we do that, we get to see something interesting. Each of these perfect fourths beats are increasing. In fact, they increase at the same speed as the same ratio as the fundamental frequencies. That is 5.95% about. But what's more important is they are not 1 beat per second. Now what about the perfect fifths? Let's do the same thing. When we take a look at this perfect fifth, FC, we find that the coincidental partial happens here at the second and third partial, and the difference is 0.59. And if we calculate all the other ones, you find this interesting thing. When they say, when people say 3 times in 5 seconds, they're saying it beats about 0.6 beats per second. Well, this doesn't happen here, does it? In fact, the only one that's close to is F3C4. The fact is that some of these perfect fifths beat faster than some perfect fourths. Take a look at these. D4A4 beating at 1 beat per second, which is what they say, people say that the perfect fourth beats at. So you got a perfect fifth here beating at the speed that people say the perfect fourth beats at. And these ones here are the ones that are, these perfect fourths are beating slower than those other perfect fifths. So, what speed do perfect fourths and perfect fifths actually beat at? Well, the calculations that we've done are not considering inharmonicity. That's another issue altogether, but it's very close. Without considering inharmonicity, the results are very close. If we consider ideal piano strings with no inharmonicity, we can make these conclusions. If we consider just the perfect fourths and the perfect fifths that occur within the temperament octave, F3 to F4, we can say that the perfect fourths beat from 0.79 to 1.18. That's a 20% error if you think that the perfect fourths only beat at 1 beat per second. And the perfect fifths, they go from 0.59 to 0.79. That can be as much as a 32% error from this myth that's taught that says that the perfect fifths beat 3 beats in 5 seconds. So this myth is one of the many that has spurred me on to figure out a better way to learn how to tune pianos orally. It's the Go Ape Aural Piano Tuning System. And if you're interested, you can go to howtotunepianos.com/Go Ape for more information. And for a limited time, there's going to be free videos on that page. The course is going to be open for anyone to look at, and that's until I get the whole thing done, and then it'll be closed and people will have to pay to get access. Okay, thanks for watching, and watch the other videos on aural piano tuning myths.